This is Hatham.
Hi.
Very interesting guy, very diverse background. First from medical robotics, which I'll tell you about in a second. Spent time in London, Boston, and now here where he runs a hardware startup incubator. So various companies working on all kinds of cool ideas. Typically when you're in a startup you like to go work at an incubator because it's a bunch of small companies like you in the same space. So you can share ideas, get to know one another. You're all kind of facing the same struggle of being a startup and trying to raise money. So Hatham started the incubator and runs it. He also has a small company that he runs as well. So he's going to share with you some stories about his career.
Okay. Hi guys, thanks for having me. I realized at the beginning that I hadn't even put my name on the slide. So, as Robbinsdale, my name's Hatham. I have a mechanical engineering background, so I did an undergrad in mechanical engineering. It's funny, like I wasn't, there's two types of mechanical engineers, right? There's the guys who, like, when they're kids, they're like, like you guys, I suppose, taking their bikes apart and taking everything they can find apart, and they really get into the sort of the engineering side. I was more just a guy who liked maths and physics, and I was like, what should I do? And I thought, oh, engineering sounds good. And so it was only once I started studying mechanical engineering that I really got into it. And then I started taking my bicycle apart, my motorcycle apart. I bought a motorcycle, a really small one, and I took it apart with some friends, and we put it back together again, and there's like 5 parts still that we hadn't put back together even properly. There's 5 parts left, and we're like, what are we going to do now? Is it still going to work? And it did work, but it had this noise that just never went away. So anyway, so I got into robots. I really like robotics, and so after I finished my undergrad, I decided to go and do a PhD in medical robots. And the reason I wanted to do that was because it's cool, right? Medical robots is cool. Like, I like robots, and then the whole idea of applying them to humans and to surgery sounded really, really cool. And so I decided to get into that. And a lot of this talk will actually be about some of the stuff I did there, which I thought was really fun. And then I have tried to start a company before, and it didn't go well. After about a year, we had to close it up. So, and now I'm starting something new, so I sort of write that I'm an entrepreneur there, but I'm sort of a wannabe entrepreneur because I haven't been successful yet, but I'm working on it, and so, but it's a lot of fun, which is the important thing. So, how many of you have seen this system before? What is it?
It's like a robot that operates surgery with the surgeon just moving the stuff in it.
Exactly. So this system is called the Vinci Robot, right? And it is probably one of the few, there's only a handful of robots that are commercially available in surgery, and this is one of them, right? Who knows how much this costs? Take a guess. How much do you think?
5 million.
Well, pretty close.
5.2 million.
No, it's a bit lower actually. So this robot, it's like when you buy a car, you can get all these extras, right? So if you get all the extras, it's about 3.5 million, and the cheapest one is about 2, right? So this is a big deal for a hospital. When they buy this, they have to make sure they're going to have a lot of patients who they can operate with because it's such a big investment, right? And this is a really complex piece of equipment. So it's really actually quite cool though. So this is the robot, and it has 4 arms. You can actually see a better picture of it here. So it has 4 arms, right? And so these arms, 3 of them, have very little tools that can manipulate inside the body. And this one over here is a camera, right? So the way this robot operates is that the patient is lying down, and it makes 4 holes in your chest or your abdomen, right? And 3 of the holes have tools in it, and 1 of the holes has a camera. And then the surgeon sits over here, sort of in this virtual reality environment. They're looking through this sort of vision piece, and they get to see what the camera is showing, right? So they get to see the inside of the body, and they have 2 little joysticks over here, right, which they hold like this. So you can imagine they're sort of like looking like this. They're moving this around, and their hands, right, are being replicated by the tools over here, right? So the tools over here do exactly what his hands do. So if he does this, the tools do exactly the same thing, right? So it's really, really cool. So of course, one of the problems is that this has 4 arms, right, and the surgeon only has 2. So they have a bunch of pedals on the floor, which you can see here. And so when he wants to change from one arm to another, he presses like as if you're pressing an accelerator, and on your car. You press it, and then it changes to another arm, and then he gets to control that arm, right?
So if it if it's just basically the surgeon controlling it, what's the benefit over having a surgeon directly doing the surgery?
That's a really good question. That's what hospitals, before they make $3 million investment, they tend to ask that question. So it can do lots of really cool things. So one of the things it can do is that, imagine that you're operating on a very, very small structure in your body, right? When a surgeon does this, right, that could be scaled down in the robot to be a tiny little motion of 1 millimeter, right? So in reality, you can sort of scale down the motions and do very delicate things that you normally just wouldn't be able to do, right? I can give you an example. One of the operations that they're starting to do with this is on the eye, right? So they're doing very, very thin, they're making very little small cuts on your eye, which you just can't do freehand because your hands tremble. So this can filter out the tremble, it can scale down your motions, allows you to do stuff like that. The other thing is that if you don't have a robot in this operation, you need to be holding the tools outside of the body like this, right? So imagine that I have a patient here, I stick in an arm inside his or her body, and I do the same over here, and I'm sort of using the arms like, it's pretty difficult to do without a robot, this type of operation. And so people do it, there's some really skilled surgeons that do it, but this allows the average surgeon to do it, right? Before it would only be like the super surgeons could do this type of operation, and now many others can do it, right? Because everyone's grown up playing video games, right? And so now they can use this pretty easily. Right? So those are the main advantages of this thing. This isn't used for every type of surgery, it's only used where those advantages make a difference. So for example, for your prostate, for your heart, and for removing organs inside your belly as well, it's used quite a lot. Okay? So actually the new version, so I was just saying, this is the console, this is the robot, and this is all the electronics that powers the robot. Okay? So it's a really cool system, $2.5 million. It's probably the only one that's around that really makes money. So this is the standard for people working in the medical robotics field. We want to be like these guys. So I was working on, this is the male reproductive system, right? And this particular organ over here is called the prostate, right? And so I was, I signed up for a PhD in medical robots thinking I'm going to do stuff like this. And my supervisor says, no, actually, what you're going to do is you're going to try and detect cancer in the prostate, right? So the prostate is a little organ, it's about the size of a walnut, right? And when you're a male and you get up to the age of 65, the chances you get of having cancer in your prostate are very, very high, right? And so what they do if they think that you have cancer in your prostate is, so this gets a bit gross, but it's only pictures, right? So they shove what is called an ultrasound probe up your butt, right? And they try and image your prostate, right? And so ultrasound is, all of you have heard of ultrasound, right? It's what they use to look at your baby when a woman's pregnant, right? So that system is very, very nice for looking at babies, but it isn't very nice for looking at prostates, right? And this is an image, typical image of the prostate, right? You can't see very well, but this over here is a prostate, right? And so doctors look at this, and they ask themselves, does this guy have cancer, right? And really, they can't really make a good decision because the imaging is pretty poor for the prostate, right? So what they do is they stick needles in, and they stick a needle into the prostate, about 6 or 7 of them, and they take a little sample of tissue, and they say, well, let's analyze the tissue and see if there's cancer, right? But you can imagine, if you're just sticking 6 needles here, what if there's cancer and you miss it, right? So that's the big problem that surgeons have. So when I started my PhD, the question was, how can we make this process better, right? People are getting older, more people are getting prostate cancer. How can we avoid having to stick 6 or 7 needles in their prostate and maybe even making a mistake, right? So, how many of you have heard of an MRI machine, right? So MRI machines are huge machines, they're about $1 million+ each. And what you do is you put a person inside and it takes an amazing image of the inside of their body, right? Amazing images. So, so our theory was, what if we could do the same thing inside an MRI machine? What if we could look at a prostate inside an MRI machine, detect if there's cancer, and maybe avoid having to stick in 6 or 7 needles into the poor guy's prostate, right? And so, so this is what the images look like. Again, you can't see it very well, but this is the prostate, right? And you can see lots of little structures in here, lots of little colors. And so this is a much better image for a doctor to make a decision, right? And even though you can't see it very well here either, this is the prostate. And this bit is darker, this bit is lighter. A healthy prostate should look white, apparently. And so if there's like a big dark patch, then it's suspicious of cancer, right? So our thesis was, hey, why don't we take the patient, put them in an MRI machine, scan their prostates, have a look at the images and decide if there's cancer. Well, that's good, but the doctor still needs to know for sure if it's cancer. So what they do is they stick a needle inside the area that they think is cancerous, right? So before you had ultrasound, you're sticking in needles sort of, willy-nilly, you don't know if it's going to hit or not. And here you can at least say, well, let me stick a few needles inside the actual area where I think there might be cancer, right? But if you look at the MRI machine and the patient's inside here, you can't stick a needle in. You can't like stick your arm in and stick a needle in the guy. So you need a robot, right? So that's where I came in. So I thought, okay, let's design a robot that can go inside an MRI machine and that can stick a needle in someone's prostate. And this was like a very crappy first prototype, right? So this is the system, and the interesting thing is it's made of plastic, right? So robots aren't usually made of plastic. And the reason this is made of plastic is because an MRI machine is like a huge magnet, right? So if you put anything metal in magnet, it will fly inside the MRI machine. And so you could potentially hurt you. So if you have a robot, you need to make it all out of plastic, which actually makes it quite difficult. So this is my robot made mostly out of plastic. It has a needle here. And of course, I didn't try this on a patient yet because it was a very early prototype. But we developed it a little more, and here's a colleague of mine handing next to the last version of the prostate robot that we had. And so that version we did try on a couple of patients, right? So we put it into a patient, into 3 patients, and 2 of them we managed to stick a needle in right inside the prostate, right? So I did this, and then I graduated, right, for my PhD, and I promised never to work on prostates again, because I was sick of it. And so I went to, I spent some time in Boston, I spent some time at Harvard Medical School, and I was working on the brain and the liver, building robots to operate on those 2 areas, and that was really fun. And I decided, okay, I don't want to be at a university anymore, I want to go into the corporate world, the real world, right? And so I got a company at Philips, I got a job at Philips Electronics, and I was building robots, but this time we're building robots for completely different things, right? So I want to show you a video, let's see if it works. So this is one of the robots we built. So this was a home lab, and we're trying to incorporate a robot into the home, right? So we're trying to make it clean. This is a very early prototype as well. We're trying to help people cook with the idea of like helping the elderly, right? This is trying to make a coffee. I'm not going to show it here, but we have the robot pouring a perfect pint of beer as well. But so this is the robot. So the thing you have to understand here is that we're showing the video, right? This took a long time to make, right? Because the robot kept failing and kept breaking. And there you go, coffee. We kept spilling the coffee. It was a nightmare to make this video. All right, so that was one application of it, and then and in reality we thought, well, yeah, go ahead.
Wait, was that someone controlling it, or was that autonomous?
That was someone controlling it.
Oh.
Yeah, it can do autonomous stuff, just not as complicated.
How do they control it?
They had like a joystick. And so we went from having a very crude joystick to having something that actually goes on your arm and allows you to move it around. So I don't know if you noticed, but the design of the robot is exactly like a human arm. So it has movements in these directions, in this direction, and in your wrist direction as well as the top. So if you put like a sort of joystick on your arm, you can replicate your movements pretty well.
Why not an action hand? Why a clamp?
Because that's really complicated. So it's much easier to have like 2 fingers that open and close. We also had force sensors on the fingers, so if you grasped a bottle, it would know that you grasped it because the force on it gets higher once you start touching it. Right? So that's how. So we thought, okay, are people really going to have these in their home? Well, maybe not, right? Because it's a bit clunky and all that sort of stuff. So we thought, okay, let's see if we can add it. And I don't know if this is a great idea either, but so this is another video that we made, where the idea is that we were going to add it to a wheelchair, right? So people in wheelchairs can sometimes sort of move a joystick, they get to move around, but they often can't reach out and grab stuff, right? So in this video, you can see that they have a little interface, a touchscreen interface, and you go and grab the bottle of water, right? And this is autonomous, right? So this is without a joystick or anything, and it's using a camera, and so it's picking up, and then it brings over and you take a sip, right? So that would be the idea. The idea would be an extension of the wheelchair, and that way you could do cool things with it if you can't reach out. Do you have a question? Or? And so I was saying that it's autonomous. So I don't know if you noticed, but on the hand of the robot, there was 2 yellow spots. And so we set it up so that there's a camera on the ceiling, and so you move the robot into the camera, and it detects the 2 spots, so it knows exactly where the hand is. And then the bottle of water, it can detect exactly where that is as well. So you just say, pick up the bottle of water, and you just move the robot until they come together. It squeezes the gripper, and then the gripper, when it starts to feel the bottle of water, it tells you you've got the water and you can pick it up. So that's how it's working. So I did that for about 2 years at Philips. It was a lot of fun. We were also working on surgical robots there as well, just not as nice as the Da Vinci one, but it was still pretty cool. And so, like Robin was saying, I left that, and now I work at an incubator, right? And so this is one of the posters we use to encourage students at the university where this incubator is to come up with ideas. So basically, an incubator is a space where you have really cool tools, things like 3D printers and a laser cutter and all this sort of good stuff. So it allows people, and Arduinos and Raspberry Pis and things like that. So it allows people to build things. And the idea is that they come in, they have an idea, they say, I have an idea to build. I can give you an example, like a device that, these little coffee machines that you put in the pod and it makes you a coffee. So they're doing the same with like protein shakes and vitamin supplements and stuff like that. We have another company that's making an exoskeleton, so it's like a vest, and it allows you to pick up things really easily. And they're using it for workers in like warehouses, right, whose job it is all day to pick up packages and they get injured and stuff. So basically, if you have an idea, you start a little company around it. An incubator essentially is a space where you can come in, you can use the tools, and you can, and we provide things like mentorship, we provide things like advice from expert engineers and advice from business people to help you develop your company. So these are the sort of facilities we have. So there's a lot of stuff that you guys actually have here. So we have microcontrollers, we have tons of Arduinos, we have Raspberry Pis, we have a few MakerBot 3D printers, we have some nicer 3D printers as well that can do some really high resolution stuff, and we have a lot of other things as well. So essentially the incubator is set up so that if you have a startup idea that you want to, and you need to prototype something physical, you can actually come there and do it, and hopefully get the ball rolling with the startup. So I'm actually working on a startup now, and so I'll tell you what I'm working on. It's so I'm really interested in like sound and speakers and that sort of stuff, and so you buy a home entertainment system, right? And you're sitting on your sofa and you have a TV in front of you, and you have like the subwoofers at the front, and you have the other speakers all around, and the effect is really amazing, right? You go to a movie theater, you can hear a helicopter coming in from the left and panning out to the right. So I was obsessed with, okay, how can we replicate that on the human body when you are, say, listening to music on your iPhone or your mobile phone, right? So you imagine you're on the subway and you'll have the same feeling like when you're in a movie theater, right? And so the way we're trying to do that is we're trying to create little devices that you stick to your clothes, and they vibrate your body, right? So, for example, we have a video game where we have a tank that comes into the screen, and so you feel your body sort of rumble because it's vibrating your body here, and then as it passes to the other side of the screen, the rumble comes to your right side. And so what we're trying to do is create the same sensation you have in your home theater, but actually on yourself. And it's actually pretty difficult because you can imagine if you're putting devices on the body, right? First of all, how do you stick them to your body? Right? Are you sticky things on your skin? That's a bit weird. Can you put them in your clothes, in pockets? So we have the first challenge that we have is sort of how are we gonna do that? The second challenge is battery life. So you guys have all seen batteries, right? like these things run out of batteries after 3-4 hours of work of vibration, right? And so we're really struggling to figure out how to get batteries going. And the other thing is that it's we use a phone that communicates wirelessly to all these things, and not all phones can do that. So we're actually having trouble connecting wirelessly. And this is all stuff that I can see some of you, sort of nodding your heads, because it's all pretty difficult problems. So that's what we're working on. And so maybe in a year or two, I think we might be able to have something on the market that can replicate what your home theater can do at a much lower cost. But we'll see. All right. So do you have any questions? Yeah.
What was it like working at Philips? How's the environment there?
So the environment is actually, it was very good. So I was working in the research lab at Philips. So research labs at Philips, basically, once a year you write a proposal and you say, this is what